So in this module, we'll start our discussion about polynomials. We are basically going to learn the introduction. See dear children, this is a very important topic, and what we need to understand is the basic of polynomials. We are first going to understand the definition of polynomials, which is very important. So what you can see on the screen right now is the definition of polynomials. But before, actually the definition is fine, but what are polynomials actually? Polynomials are algebraic expressions. And children, you have studied the algebraic expressions. What are the algebraic expressions? Algebraic expression contains terms and at least one variable, and it was an expression, means what? It had plus and minus signs in it, correct? Terms were having coefficients and variables, but plus and minus signs used to differentiate the terms, and those terms combined together used to give us an algebraic expression. Very quickly I'll write down a few examples of algebraic expressions what we have seen. So what you can see here on this board is that now, see, these are the few expressions. 2x plus 3y, okay? It has got terms separated by the addition sign, or 3x square minus 7x plus 7 terms separated by plus and minus signs, or something like this, fractional coefficient 4 upon 3 x raised to 5 minus 7 root x, all these. Now, if I write this 3 plus 2, what was this? Do you remember what was this? We called it last year while learning algebraic expressions. This we used to call as an arithmetic operation, arithmetic expression, because it contains only numbers and the arithmetic operators, that is plus or minus sign along with multiply division, but only numbers. It remains arithmetic. But the moment the variables get introduced, it becomes an algebraic expression, and our polynomials are nothing but the extended part of algebraic expressions. So first thing we need to understand, revise, recall our algebraic expressions. So let me again give the definition. Algebraic expressions are those who have terms separated by plus or minus signs and having at least one variable. At least one variable is important, okay? So here there is x and y, here there is only x as a variable, here there is again only x as a variable. So two variables are allowed, one variable is allowed, many variables are also allowed. But right now we are going to study in this chapter polynomials, means polynomials as those algebraic expressions in one variable only, say x. So we are going to learn polynomials in terms of x. We are going to restrict ourselves this year for polynomials in one variable x. But what are polynomials? Polynomials are special types of algebraic expressions. Which type? That we are going to see. So what you can see right now on your screen, this is also the definition. Let me say the definition. Polynomials are those algebraic expressions which can be written in the form a1 into x raised to n plus a2 into x raised to n minus 1. See, a1, a2, a3, it goes on increasing. The power of x goes on decreasing. X raised to n, x raised to n minus 1, x raised to n minus 2, and so on. Ultimately, the power of x becomes 0, means the decreasing of, we are right, this is the standard form of polynomials. But yes, algebraic expressions written in this form such that, very important point, the power of the variable, and children, here the variable is x, the power of the variable x is a whole number. This is a very important condition. You have to understand it. We are interested in the power of variable and the power of variable only. We are not interested in the coefficients a1, a2, a3, an. All these are coefficients. They can be any damn thing. They can be fraction, decimal, square root, negative, positive, doesn't matter. But the power of x cannot be negative integer, cannot be a fraction, cannot be a square root. this power has to compulsory be a whole number. Okay, so I'm repeating the definition. This is the form a1 into x raised to n plus a2 into x raised to n minus 1 and so on till an into x raised to 0. What we are going to do is that very quickly I'll write down a few examples, and using those examples we'll try to understand exactly what does a polynomial mean. But the simple thing is, it is an algebraic expression. Why? Because it has a variable x. At least one variable x is present, and due to the presence of this variable, it becomes an algebraic expression, and algebraic expression written in this form becomes a polynomial. It's very important. Let me write a few examples. So what we can see over here is that 7x raised to 5 minus 4x cube plus 2x plus 3. This was our algebraic expression. So this is also a polynomial. Now, see what happens in this polynomial. The power of x is 5. X is 3. Power of x is 1. Correct? And now, this constant number 3, we always know that anything a raised to 0 is equal to 1, law of exponent. So this 3 is nothing but 3 into x raised to 0, the final thing. Always it will be x raised to 0, because x raised to 0 is 1, 3 into 1 does not change, it remains 3. So what are the powers? 0, nothing means 1, 0, 1, 3, 5, all are whole numbers. So yes, the condition is satisfied. See what? Algebraic expression. Why algebraic expression? Because it contains terms separated by plus or minus signs. Further, having at least one variable x, hence an algebraic expression. And all the variables having powers which are whole numbers. Now dear children, this definition you may not find in all the books. That is why I am giving you a definition. Very, very important. Algebraic expression such that powers of the variables are whole numbers. No negatives, no fractions, no roots. Here again, algebraic expression. Yes, because at least one variable. Power of the variable is 3. Here what would it be? Y raised to 0. Exactly. Now, so this is again a polynomial. Again, let me give you another example. 7x. Do you think it is a polynomial? Yes or no? Exactly, it is a polynomial. And we had named this polynomial. What was this? Monomial. Single term. Hence we called this monomial. 2 terms we had called it binomial. 3 terms trinomial. And 4, or in general 1 or more terms, it would become a polynomial. So all these were polynomials, but this is a special polynomial called as monomial. Single term. 2 terms binomial. 3 terms trinomial. 4 or any other number of terms, it would be simply called as polynomial. That was our definition last year. But this year we have added, we have made ourselves little bit clear that the power should be a whole number. Last year we had not said that because we didn't give you those kind of examples. But now you understand that power cannot be negative, or under root power has to be a whole number. What I'm going to do is that we'll write few more examples and try to now understand whether they are polynomials or not the polynomials. So what we can see in this example is 2x square minus 7 upon x. Now tell me children, can this be a polynomial? Is this a polynomial? Again we'll go back to our definition. What? Algebraic expression. Is an algebraic expression separated? Is there are some terms separated by plus or minus signs? Having some variables? Yes, an algebraic term. Moving ahead, the powers must be whole numbers. Here the power is 2. Here what is the power? Nothing means what we call it as 1. So this is 7, but it is upon x raised to 1. Do you remember what was our next law? 1 upon a raised to m is equal to a raised to minus m. So here this would actually be is equal to 2x square minus 7 into x raised to minus 1. And this power is not a whole number, it is an integer. This expression cannot be a polynomial because our powers cannot be negatives, cannot be square roots. So now very easily you can tell, is this a polynomial? No, because it is a root. No. Why? Because I had told you we are not interested in the coefficients. Coefficient में कुछ भी रहने दो, हमको कुछ फर्क नहीं पड़ता. We are interested where? In the variable and its now this is 11 upon 2. Means should I write it 2 raised to minus 1? Not needed because coefficient से हमें कुछ फर्क नहीं पड़ता. We need what? The variables. Power of p is 2. Power of p is 1. Yes, this is very much a polynomial because algebraic expression. And powers of variables are whole numbers. Similarly, one more very quickly example if I take say 7 root x minus 3x square plus 11x. Is this a polynomial now? No, because this is root x and you know that root a is a raised to half. Root x means what? 7 into x raised to half. Again, the power is not a whole number. Power has become a fraction, not allowed. So, is not a polynomial. Why? Because the power was a fraction. So ultimately this definition becomes very, very clear that we are not interested in the coefficients. We are only interested in the powers of the variables. Coefficient can have any kind of power, root power, negative power, fractional power. But the variables should have only and only whole numbers as their powers. So that is what polynomials are. The next point what we are going to see in this model is about the degree of the polynomial. This is a very, very easy point but an important point. What is degree? Degree is nothing but the highest power of the variable. In a particular polynomial, whichever is the highest power of the variable, that becomes the degree. Let us see an example. So now here, if you look at these examples, see this is the first example. 7x raised to 7 minus 3x square plus 2x raised to 5. Correct? Now is it a polynomial? First of all, we will decide whether it is a polynomial. Yes, it is satisfying all the conditions to be a polynomial. It is a polynomial. And what are the degrees? 7, 2 and 5. What are the powers? 7, 2 and 5. And highest power is the degree. Which is the highest power? 7. So automatically the degree of this polynomial becomes 7. Degree becomes 7. So now you tell me, what is the degree over here? What is the degree in this polynomial? 32? Should I write here degree 32 now? Am I right? No, dear children. Why the degree cannot be 32 over here? Because 32 is the power of 2. And I have told again and again, we are nowhere interested in the coefficients. What do we want? We want the variables. And the power of x variable over here is 1. And here variable is 10. Who is higher? 10. Degree is not 32. Degree is 10. ये 32 हमारे कुछ काम का नहीं है. Correct? Now similarly here 3x cube minus 11y raised to 11. Now this is a polynomial in two variables, and out of those two variables this variable has got a higher power, so obviously this becomes the degree. The degree of this polynomial becomes 11. Similarly this 4x raised to 1 and constant term nothing. 7 means what? 7 into x raised to 0 because x raised to 0 is 1. So either 1 or 0, higher power is 1. So the degree becomes 1. So that's the very, very easy part. Degree of a polynomial is nothing but the highest power of the variable. So now moving ahead, what we are going to see is the types of polynomials. Now last year, dear children, we have already studied the types of polynomials. One type, that is depending upon the number of terms. When we had single term, we call it as monomial. 2 terms, we call it as binomial. 3 terms, we call it as trinomial. You know it very, very well now. Binomial, monomial, binomial, trinomial. Correct? Now this year, we are going to study a new type of classification, new names for these polynomials depending upon their degrees. Now let us see what happens depending upon the degree. So Depending upon the degree, we have 3 or 4 types. This is what I've shown over here. See, when the degree is 1, degree means what? Highest power of the variable is 1. We call it as a linear. The word is linear polynomial. So see here the variable's power is 1. 4 upon 11 x raised to 1 minus 3, or 3 into x raised to 1. Correct? So degree is 1, it becomes linear. Similarly, when the degree is 2, it becomes quadratic. See here, power 0, because 7 means what? 7 into x raised to 0. Power 0, 1, 2. Highest power is 2. That means degree is 2. Degree 2, it comes under the quadratic equations. Again here, degree 1, degree 2. Power 1, power 2. Highest power 2, degree 2. Degree 2, quadratic. Degree. Is this a polynomial? First of all, because of the presence of roots? Yes. Why? Because root should not be for the variable. Again, the same point. Coefficient कुछ भी रहने दो, constant term कुछ भी रहने दो, but the variable should not have a root. Variable is a whole number. This is a 2. So degree 2, quadratic. Similarly, the third would be degree 3, cubic. We will call it as cubic. Example, x cube minus 11. Highest power is 3, or x cube minus 11x square plus 7. Highest power is 3. It becomes a cubic polynomial. Now, linear polynomial. See, it's very important. Linear polynomial, degree is 1, but the terms may either be 1 or 2. So it can be a monomial, can be a binomial, but it is linear. Similarly, degree 2, maximum terms is 3. It can have 3 terms, 2 terms, or just let me say x square. Is it a polynomial? Yes, of course. Why? Algebraic term, and then having a power which is a variable, a power which is a whole number. So x square, monomial. Monomial, but a degree 2, hence a quadratic. Similarly, see, so linear will have either 1 or 2 terms. Quadratic will have minimum 1, maximum 3. Cubic, minimum 1, maximum 4 terms, and so on. And all other polynomials, degree 4, 5, 6, 7, will generally be called as polynomials. So again I am repeating myself. Degree 1, linear, can have 1 or 2 terms. Degree 2, quadratic, can have 1, 2 or 3 terms. Degree 3, cubic, can have 1, 2, 3 or 4 terms. And any higher degree will simply be called as a polynomial. So that's about the degree of a polynomial. Very quickly we move to the next point, that is a standard form. Again easy. Standard form means what? We will rearrange a given polynomial with the decreasing power of the variable. See, let us see an example. So what we can see, this is an algebraic expression, a polynomial which is also 3 terms, hence a trinomial, with a degree 3, hence a cubic. Till here we have reached. But now when I want to arrange this, see, this is 7 means what? Actually 7 means what? 7 into x raised to 0. So 3, 1 and 0. So I will arrange it in the decreasing order. So first term will be this, along with its sign, minus 11x cube plus 14x. This is 7 means plus 7, and 7 means 7 into x raised to 0. But still, this is 3, 1 and 0. That 2 is absent. Degree 2, power 2 is absent. And you know that. Last year also I told you. Whenever you introduce, now we introduce a term with a degree 2, but a 0 term means what it will ultimately be? Minus 11x cube plus 0x square plus 14 into x raised to 1 plus 7 into x. So this was our definition, if you remember. X raised to n, n minus 1, n minus 2, and finally n raised to 0, x raised to 0. 3, 2, 1, 0. Decreasing order of the power of the variable. Decreasing order of the power of the variable. Suppose if I had by chance a 4 over here, then this would have been 4. So again it would have been plus or minus 0, because 3 and 2 is absent, and this minus 11 into x raised to 4 would have been the first term. 4, 3, 2, 1, 0. Whichever terms were absent, x cube term is absent, x square term is absent, we will introduce those terms and complete the standard form. But the simple thing, standard form is what? Arranging a polynomial, arranging the terms of a polynomial in the decreasing order of its variables. The next point what we can see is constant polynomials. Now again, this is again a very important point. See, the word itself tells you constant. What is a constant? See, for example, see 7x square minus 7. Okay, this was the variable term. This was the constant term. Why did we call this as a constant term, children? Because it never changed its value. 7 remained 7. This term could change its value. Why? Because if the value of variable changes, the value of the term changes. But the constant does not have a variable, so its value will never change. Correct? So, this was a variable term and this was a constant term. Now, when I say about constant polynomial, I am going to make a very important statement. Every real number is a constant polynomial. What am I saying? Every real number. What are real numbers? Rational as well as irrational. Quickly I will write few rational and irrational numbers. So all these you can see, we knew that the natural numbers or the wholes or the integers, rational numbers, or another example, if I write 7 upon 3, p upon q from all rational numbers, irrational numbers. I just now said all the rational numbers are constant polynomials. Why polynomials? See, because 3 can be written as 3 into x raised to 0. So it becomes an algebraic term having a variable with a power as a whole number. Minus 7 can also be written as minus 7 into x raised to 0. Root 3 again, root 3 into x raised to 0. This is again 7 upon 3 into x raised to 0. So all these have turned now into polynomials because x raised to 0 is 1. 3 into 1 is 3, the same number. Minus 7 into 1 is minus 7. Root 3 into 1 is root 3. So x raised to 0 does not change the value. This remains a constant. And now tell me what is the degree of a constant polynomial? Obviously the degree is 0. So all the real numbers are constant polynomials and the degree of a constant polynomial is always 0, but the most special real number is 0. What is this Mr. 0? Very, very important, which our India has given to the world. But where does this 0 stand? 0 is not a constant because 0 is not constant. 0 does not come into constant polynomials. Where does 0 come? Try to think. Where will this 0 come? So this number 0, how can I write this as? Should I write it as 0 into x raised to 0? Just now as we were writing for constant polynomials, because x raised to 0 is 1, 0 into anything is 0, so it remains 0. Okay, what if I write 0 into x raised to 10? Okay, let me put any value for x. Okay, 2, 3, 5, 10 raised to 10. But multiplied by 0 again comes out to be 0. This is also correct. This is also correct. 0 into x raised to 12. Again 0 means this is 0. 0 into x raised to 100. Yes, again 0. So now what is the degree of 0? Or 0 into x raised to infinity. Still the answer is 0, which is this. Means this 0 is definitely a polynomial because it can be expressed as a polynomial. So this 0 is a polynomial now, which will be called as now a 0 polynomial. And what is the degree of this polynomial? Infinity. Why? If you say infinity, I'll say 0. If you say 0, I'll say 10. If you say 10, I'll say 30. Anything I will say. I can contradict. And when every degree gets contradicted, that means, last and very important point, the degree of the 0 polynomial is not defined. So 0 is such an important thing that you can't even define the degree of 0. Such important is 0. Such important mathematical number India is given to this world. That is our 0 polynomial. Do not underestimate the power of 0. So that's all about the introduction of polynomials. Very quickly, I will revise the points what we have discussed. You are going to write down this each and every point in your notebooks. understand the definitions and the examples. So today in this module, we had seen the definition of a polynomial, that the algebraic expression in which the power of variable is always a whole number. Then we saw the degree of the polynomial. What was the degree? The highest value of the variable. Depending upon the degree, we called it that linear, quadratic, cubic. Degree 1, degree 2, degree 3. We also knew it as monomial, binomial, trinomial. Moving ahead, we also saw the standard form of a polynomial. So what was the standard form? Arranging it into the decreasing order of the variable. Moving ahead, we saw the constant polynomials. Every real number, rational as well as irrational, could be expressed as a constant polynomial with the help of x raised to 0. Hence, every real number was a constant polynomial. And finally, the special number 0 was our zero polynomial with a degree undefined. So that's all about polynomials, dear children. Hope you have understood this. Watch the video again if you want. Write down the important points. Right now, that's all from my side. Thank you.